All right, let's get started. So as we voted last time, this week is going to be just whatever I come up with. So hope you enjoy. I'll come up with something that I think you'll like. I do owe you some final exam talk, so I do want to talk about that a little bit. Before that, first of all, the incentives. We did hit the first incentive, so we finally unlocked genetic algorithm. I'm hoping we get to point of sale. I think that's the one most people need, and I honestly thought we'd be at 70% sometime mid last week. So it's kind of wild that we're not there to me, but we are at 61. The auto grader is unlocked for genetic algorithm. It's accepting submissions till December 10th. Right now, it will still say, I have the version of the grader that says you can't get credit for AOs anymore. I'll update that as soon as I get home. It's on my other laptop. I said it all right here. But that's on my other laptop, so I'll update. But you can still get credit right now, even if you get credit before I upload the old grader that accepts application objectives and gives you your score. And you don't re-upload after I do that, you'll still get credit. I'll still look through those, and I'll make sure you get credit for those. You'll still rightfully earn that credit. So those are unlocked, and you can earn credit right now. Even though it says you can't get credit for the AOs, it does still give you all of the feedback. As usual, it just says you can't get credit, and then it won't add it to your score. It'll say AOs 0. But if your feedback says you got credit for that AO, you got credit for that AO. I'm going to make sure you get credit for that. But as long as I remember, as soon as I'll get home, I'll update that. If not, like tonight or tomorrow, whenever I remember to do it, and I'm with my other laptop. But we're separated right now, all the way at my house. So we'll wait for that. Evaluation Center, just to verify, we're still at 61%. I've been updating this like way more than I should. Like probably at least every half hour, I'll go to that evaluation page and refresh. So this is up to date. It's really current, especially when we were sitting at 59. I was refreshing a lot because I want to make sure I unlock that as soon as people fill it out. With the Evaluation Center, I'm allowed to send one email to everybody who has not filled it out yet. I did do that over the weekend. I no longer have the option to send an email. If you're really observant, you notice there are 4 options here. Last time I showed this in lecture, I only have 3 because I sent out those emails. I expected a huge influx of submissions as soon as I sent that email. That didn't happen. So I'm a little less hopeful that we'll get to 70%, but I'm still hoping that we get there. Maybe those students just aren't checking their email until tonight. Maybe they don't check their UB email over the weekend. It's perfectly acceptable, but we'll see. Hopefully we'll get there up to that 70%. That's the magic number I think that benefits the overall the class the most. So hopefully we get to 70%. But I'm out of options except emailing the entire class. I don't like to do that because I don't like to bother everybody who did fill it out. But if we're getting there, if we're like Wednesday night sitting at 68%, I'll send out an email. And web applications doing a lot better. They always do. I think my incentives are really strong for those. It really motivates them to fill it out. And hey, you're beating 442. Maybe everyone filled it out right when I said that. Nope. I refreshed that way too much. All right. Let's do a little bit of final exam talk. So for the final exam, I'll tell you right now, I'm not 100% decided on the logistics of the final exam yet. So it may or may not be a Google form. If we're all doing it in this room, actually, is it in this room? I didn't even put the room down. I assume it's in this room. I'll double check before the time comes. But if we're all doing it in this room, I don't really want to do it with a Google form in case you didn't bring your laptop or something. I don't know. So it might be on paper, but whatever. Whatever it ends up being for logistics, it's going to look very similar to this. This rectangle here drives me nuts. That's where I should hide all my secret stuff. Right in there. So this is about what it's going to look like. This is about the level of detail that I'm going to give you. The final exam questions are very open-ended intentionally because I'm testing your ability to take a very general, vague problem statement defined by user features. These are features that users want to use, And I want you to be able to take everything you've learned in this class and be able to design, or at least architect, software based on that. Can you take what you've learned about testing, OOP, FP, concurrency, data structures, and design software using all of those ideas? That's what I want to know. So the questions are going to be pretty vague. This is the example I've been given very vaguely earlier, but a banking system. If you're building a banking system, and users want these features. They want to be able to deposit funds, withdraw funds, they want to take out loans, they want to manage their payments, make payments on their loans, not manage. They want to be able to make payments, maybe manage if you want to have an automatic payment system, that's fine. Transferring money between bank accounts owned by different people. So there's a bit that you can think about here. Each bank account should, should probably be a class with an owner, and then check that owner, a lot of different things you can do to make sure that you can transfer that money between different people, and then managing different types of accounts, at least checking, savings, and investment accounts. So hopefully when you read that one, you think polymorphism, inheritance, that's your OOP one. This is basically my way of saying you're using OOP right here. So hopefully nobody gets the OOP one wrong. You should have an account, abstract class, and then 3 concrete classes that extend that account class. And then you can talk about inheritance and polymorphism and how you're going to use that. A lot of my banking functions work on the account class and doesn't care if it's checking, savings, investment. Doesn't care. They're all going to have a balance. You're going to be able to withdraw from any of them, deposit to any of them. And then each of them also have these extra additional features. You can write checks over here. You can buy stocks over here, buy and sell stocks over here. And you can earn interest rate over here. So those are the features. And that's all I'm going to give you. That's it. That same level of detail for any of these, I'll give at least 3 apps like this, at least 3 ideas, and then you'll choose your favorite 1 or 2, depending on how many AOs you still need. And it's up to you to do the rest. So tell me everything that you're going to do, how you're going to design this software. Just go nuts. Give me the idea of how you're going to build this thing. And then specifically, I have 4 extra questions for each learning objective. At least point out in your design, or explain in addition to your design where you're going to use each of the 4 learning objectives. So how are you going to test this thing? LO1 was really all about testing. We also learned Scala in there, but I'm not going to be like, where are you going to use Scala? Like, I don't know, the whole thing. So testing was the first 116 topic that we learned. It was the only 116 topic in LO1, with the exception of stack, but that's hard to ask about too. You're always going to use the stack whenever the program runs. So testing is the one that I can really ask you about for LO1 here. So describe those test cases. I don't want to see any code. Don't write any code for this entire thing. But describe in English. What are you going to test? Well, I'm going to create 2 bank account objects, and then I'm going to deposit money in each of them. I'm going to call transfer money from this one to this one, and make sure the money's transferred, make sure this account is this and this account is this at the end, for example. So give me a bunch of test cases. Show me that you understand how to test code. Where'd you use OOP? I don't want to know classes. Hopefully you understand how to use classes and objects by now. If you don't, you wouldn't have made it through the learning objectives. So for the application objective, show me where you used inheritance and polymorphism, the other OOP topics, the ones that got a little deeper. Inheritance, polymorphism, or even apply those and talk about a state pattern. You want to apply a state pattern to your code. That would be awesome too. But show me some object-oriented programming, not just I'll create a class named bank account, I'll create a class named savings account, a class named checking account, and a class named investment account, and those will be classes. I'll use those to create new objects. I don't want any of that. Show me the inheritance and polymorphism. I'm going to create an abstract class called account. It's going to have these methods, and I'm going to extend that in these 3 other classes that I create. So don't just be like, I'm going to create some classes. Show me some inheritance and polymorphism. And I should probably make that. Did I make this explicit? Yeah. E.g., inheritance, polymorphism, and state pattern. I guess you could talk about GUIs. I might remove that, but I don't want you to just say, oh yeah, object, classes. Show me some inheritance and polymorphism. For 3, show me some functional programming or concurrency. I'm going to leave it up to your choice here. Any of the LO3 topics, they're all fair game, including the concurrency. So for a bank account, well, you want multiple users, right? Is this going to be a web app? Which I think I require, right? I do say web app. Online, yeah. It's an online system, so you're going to be naturally concurrent. You want multiple users to be able to use your app at the same time. You're going to have concurrency. You can talk about that. You can talk about a place where you're going to use some recursion. Maybe you want to explain how you use immutability. First order functions would be a little contrived if you choose that one, but go for it. If you want to talk about a place where you could use a first order function, would be cool too. And finally, LO4, talk about, not a linked list. Talk about where you can use a tree or a graph as a data structure. So this one will almost certainly be a little contrived, but talk to me about some place where you could use a tree or a graph to be able to do something in your app. So some type of data that can benefit from one of these two structures. A list is too easy because pretty much, I don't know, I'm going to have a list of transactions at some point. Like I'm going to have a list of bank accounts. That's too easy. You could just say literally anywhere, I'll use a list. But a tree or a graph, come up with some place where it makes sense to use those. Maybe it's a graph of accounts, and then the connections between them is, has money ever been transferred between these two accounts? Money was transferred between accounts, and you catch somebody dealing drugs over here. They had a big cash deposit, and they were moving money around. And you have somebody over here that you suspect being involved. Well, what's the distance between these two accounts? If that distance is like 2, well, especially if it's 1. But if that distance is like 2 or 3, you can be a little sus about that. If that distance is infinity or like 20, well, okay, maybe we'll let them off the hook, and maybe we could use that as evidence in a court. In a lawsuit or something, or a criminal case even. So that's what I would contrive if I was taking the final exam and doing the banking system. So come up with something like that where it makes sense to use that data structure and the things that we use that data structure for, either trees or graphs. And as long as you satisfy all 4 of these, you'll get credit for that application objective. I'll be open with you. I'm fairly lenient on the grading of these things. I lean towards giving you the application objective. Other than that, I don't have any formal rubric that I'm showing you, so it's kind of hard for you to tell exactly what I'm looking for on each of these. So I am a little bit lenient. Don't stress too much over all of the little details. I won't say don't stress at all, of course, but I will be a little lenient on the grading. But you do have to show me effort. That's the biggest thing I'm looking for. You got to show me effort. You have 3 hours to do this exam. If you knock out 2 of these and then blitz at like 30 minutes, you're not getting credit. Like if you submit 30 minutes into this fucking thing, this damn thing, and just show that all you did was like type up some random crap and then leave, you're not getting credit. But if you're staying for the 3 hours or even 2 hours, I usually say spend at least an hour on each one. That's probably the instructions I'll have on the exam itself. Spend at least an hour on each one. Give me some good thought, actually dig into your brain and your understanding of all the 116 topics and just show me that you thought about this stuff. Show me that you understand the concepts and that you can apply them, even if the applications are fairly contrived. Like your banking app probably isn't actually going to try to catch drug dealers. That's not your job as a banking app. But even if you have to contrive something like that, that's fine. Just show me that you've thought about this stuff and thought about the content of the course for a reasonable amount of time. Don't be leaving in or on one of these. First of all, I'll have the timestamps for submission. Even if we do paper, if you hand it in what I would determine as too early, which would be before an hour, for 1 or before 2 hours for 2. I'm going to put your submission in a separate pile, and we're going to grade that very differently. If you submit in a half an hour and you have a whole lot of really thoughtful content in there, whatever. But I'm definitely going to look at those ones differently. And if it's a Google form, I have the timestamps. So keep that in mind. I'm looking for effort, but I'll be fairly lenient if if your use of recursion was really like a little bit too contrived or lacking detail, depending on exactly what you say. Some students like to say, I'll use recursion to do this method, to do account transfers. Yeah? Talk to me about how. Tell me, give me details. Show me that you understand recursion. That's what I want to know. I want to know, can you take this thing that we learned in class and apply it to a real world problem? That's ultimately what I'm looking for. So show me that. So it's an application objective. Can you take what you've learned through the learning objectives and apply them to solve real world problems? If you keep that in mind through the exam and give me a good amount of time of thoughtful effort, and you actually understand the stuff. Like if you're someone who probably shouldn't have even gotten through the learning objectives, that's going to show, and you might not get credit. But show me that you actually understand the content of the course and get it on your submission. Any questions about any of this? Yes.
Say for the first semester you close it out, can you also submit that to justify the answers?
If someone, I missed part of that. If somebody pulled that out and then, what was it?
Someone actually coded it out,
I don't want to see code. Like any code, I'm going to ignore. I'm just going to read the English sentences that you submit. The code is just going to waste your time when you write it up. So think about the code you would write, and then if you do submit some code, that's fine, but it's not going to gain you anything. So think about the code you would write, and then just explain it in English. I'll have a class named this. It's going to have methods, this and this. It's going to have these state variables that it's going to keep track of, and these methods will do this. This method will do this. This method will do this. So explain what you would code without the actual code. Plus, it can be not necessarily on this exam, but that can be a double-edged sword in some cases, in some other classes, where I'm thinking 331 specifically, you're sometimes asked to write, to explain your algorithm, how it works. And some students' explanations will be like, yeah, that makes sense, that's good, would be full credit. And then they'll also include code, and the code is technically wrong. Well, at that point, I'm marking off points for that. So that can be a danger. I don't think I would do that in this class since it's pass-fail. I'm not going to fail you for a small bug in the code you submit. But you are running that risk where the more detail, I don't want to say it like this, but the more detail you give, the more opportunities there are that you're going to make a mistake. So you don't really want to give the code because your explanation might be fine at a high level of detail, but once you get into the lower level details, you might expose some misunderstanding. That makes sense? I don't know. But if you want to submit some code, that's fine. I'm just going to ignore it for the most part. Does that answer your question? I think I rambled on for a while there. But, yeah. The entire thing would, that's your answer. Yeah, the entire thing. So all of this whole form is one application objective. If you get all of the learning objectives on this and show me that you can apply all 4 learning objectives, that's going to get you one application objective. There are going to be 3, probably 4 forms like this. This would be the form for the banking system with these features. There will be 3 other forms with 3 other app ideas with lists of features like this. And then you'll choose 2 of those to do, and that would be your 2 application objectives. So you're going through this process. If you want both application objectives, you're going through this whole process for 2 full apps. You're filling out 2 full Google Forms if we do it with Google Forms, or 2 full sheets of paper if we're doing it pen and paper. User not in sudo is formed. This incident will be reported. Yeah. AM root. That's on one of the CSE servers. I think that we do that on all CSE servers, but probably Timberlake you're messing around on. You're reported. The sysadmin's coming after you. Ken Smith. I don't think they literally I mean, unless you're doing something really egregious, but they usually look up what you're doing and you're usually just trying to install something. Or you just wanted to use sudo just to see if you had sudo. But if they see you're doing something egregious, don't do that. I'm telling you, I refresh this way too often. But this number is going to be accurate. Within an hour at most. Okay, anybody have questions about anything? Now, I'll take a look at I just looked at this right before lecture again. There's really not much new. I did recursion last lecture. I did this a few lectures ago. I mean, if you're still suggesting that, you probably didn't show up to lecture. I mean, I'm not going to keep going over things over and over for people who haven't watched the review lectures. Unless there's something more specific in this, but I went through like all of LO4 that one day. If there's something else you want to see related to that, but I assume this is someone who didn't watch that lecture, 3 people who didn't watch that lecture. But if you watch that lecture and there's still something more that you want to see, I'd be very happy to cover it. Tracing the heap and stack with breadth first search. Sorting merge sort. Sudo remove Ken Smith. Yeah, that one they might come after you, Nicholas. Tracing through the heap with BFS. I mean, I could do that. The thing is, I never asked you to do that on the quiz. I won't talk about the heap with BFS. Yeah, I think I'll skip that one, the heap with BFS. I mean, I can do it quickly, I guess. 16 examples. Debugger. I won't spend too much time on this. There's really not much interesting to talk about the heap anyway. So the heap is, the graph, and the graph is one big chunk on the heap. It has references to other objects on the heap as well. Like all the nodes are separate objects on the heap, and we have references. Oh, actually, they're integers. Integers and strings. I guess strings are technically on the heap. But the whole graph is on the heap, with the nodes and adjacency list as 2 other objects on the heap, 2 other hash maps. And then as we go through the algorithm, we're going to have explored on the heap, to explore on the heap, and then nothing else really gets created on the heap. We're just going to those data structures and not even modifying them because they're, actually this is mutable. And we're just going to those places on the heap to get out of here. To retrieve our data and update our data. So for example, we're going to go to the graph.adjacency list. We're going to get the node to explore, which is 0, our starting node at this point. So we're going to go to our adjacency list and look up 0, which is right here. And we have this list 4, 3, 2, 1, and we're going to iterate over those values. There's really not much to talk about on the heap. Just objects on the heap are going to get updated. not so much as like linked lists or something where there's a lot of interesting stuff to talk about with the heap. To explore, we're going to enqueue that. So we have just the value 4. The front and back are both the same node. We're referring to the same node here. We're going to update that in our explored set. So we have 0 and 4 are explored nodes. And we're going to explore 3. Add it to our linked list, add it to our set. So then our explored is going to be 3. So 0, 4, and 3 are explored. And we're just going to keep going through the algorithm. Is there something specific you want to see in this one? I don't know. I don't have much interesting to say about this. I'm just going through the code. It's not that important, that's fine, okay. Because it's all stuff I've tested on before, and it's not something I test explicitly on for LO4. Sorting and merge sort. Cole, I don't know if you're joking or not. I can never read you. So merge sort, I'll give a quick overview of merge sort. So merge sort, we're going to take a list that we're going to sort, and we're going to throw recursion at it to figure this out. Our base case is going to be a list that's length less than 2, either an empty list or a list of length 1. In either case, that list is already sorted. So I'm just going to return it. If that list has more than one element in it, I want to make recursive calls that get me closer to the base case. So I'm going to do some minimal amount of work that gets me closer to the base case, and then assume that those recursive calls return the correct answer, and then I'm going to build my logic around that assumption to be able to get the final merged, final sorted list. So to get me closer to the base case, I'm going to split this list in half. Minimum amount of work I want to do is nothing. I'm going to split the list in half, get 2 halves. Each of those 2 halves are closer to the base case of a smaller size. The size decreased for both of those lists. So success, I'm getting closer to the base case. Split this thing in half and call my recursive algorithm on each half. I'm going to assume that's correct because I got closer to the base case. So I have 2 sorted lists. Each half of this list is sorted. I have the left half of the list sorted, the right half of the list sorted. I'm assuming that's correct. That's how we're doing our recursion. That's going to be, we're assuming it's correct, but it will be correct by the time we hit the base case. So when we hit the base case, these are correct. Our assumption is obviously trivially correct for the base case. Now when you have a list of size 2, you split it into 1 and 1, you're getting the base case returned for both of those. So your assumption is true. And now if all of your logic is true, based on that assumption, you're going to be returning a list of length 2 that's sorted. Now when we have a call of this that had a list of length 4, split it into 2 lists of length 2, made 2 recursive calls, which each made 2 recursive calls, which returned trivially the correct answer, had some logic to return 2 lists of length 2, which are correctly sorted. Well, now when we have a list of length 4, our assumption is true because we have these 2 lists of length 2, which are sorted because of our logic was true. And then if our logic's still true, we're going to be able to take 2 lists of length 2 and return a sorted list of length 4. So now anybody making a recursive call with a list of length 4, starting with a list of length 8 or 9 or 7, that assumption is true as well. So I say assume it's true, but if we're getting to our base case eventually, it's obviously true because it's the base case. It's a list of length 1, it's already sorted. There's nothing that can go wrong there. I say nothing, but some smart ass could input null into this thing and everything crashes. But but that's true, and then if our logic is true, starting with the base case, recursive calls that reach the base case that return trivially true, if our logic is true, we're returning larger answers that are also true, that are also correct. And then combine those, larger answers that are correct, larger answers that are correct. So our goal is to take these two recursive calls, these two outputs of the recursive calls, assume that they're sorted, assume everything's good, and then build our logic around that to be able to return the entire input sorted. And for that, we're going to merge those two lists together. We're going to take these two sorted lists. We assume that they're sorted because we made a recursive call, and we're assuming our recursive call is correct. And then we're going to sort those two halves together with the assumption that they're already sorted, which is a very important assumption in terms of runtime, at least. In terms of everything, actually. If you can't assume they're sorted, we didn't gain anything. We just have to we squish them together and just sort them. So merge sort wouldn't do anything there. Merge sort relies on the fact that these two lists are already sorted, and then we're going to merge them together, which I had a few ways to do. The easier one to read, I'm going to start with a pointer pointing at the first element of each list, compare them. Whichever one comes first, I'm going to copy to an output list, and then advance that pointer. So I'm going to start by pointing at the first element of each list, compare them. Whichever one comes first, I'm going to append that to a sorted list, my output list, and increment the pointer. I'm going to do that until I reach the end of one of the lists. Once I do that, I'm going to copy the rest of the other list over to the output and then return that. So I'm successfully merging two sorted lists together into a list containing all the elements from both lists in sorted order. And then that's what I'm going to return. So if I start with the base case, I have two lists of length 1. I have a list of length 2. I split it into two lists of length 1. These are already sorted, obviously, because they're length 1. And then I go to my merge algorithm and get the correct element first and the other one second. And I return a list of length 2 to whoever called that method. Now, whoever called that method has a list of length 4, made the recursive calls with two lists of length 2. Those came back true. Those came back sorted. And we want to merge them to a list of length 4 that's sorted. We get two lists of length 4 that are sorted. We merge them to a list of length 8, so on and so forth, until our original list, which could have 1 million, could have 1 billion elements, who knows, that whole thing is going to be sorted based on this assumption. Our assumption's correct because it's trivially correct, and then our logic is sound. Then our assumption turns out to be provably true. We don't do proofs in this class, but in 250, you'll prove that those are true, and in 311 or 331, you'll prove that that assumption is true. Which you should have seen induction by now, right? In 191, those of you taking 191, you've seen induction. The answer was no last time. Did they just not teach induction in 191 anymore? They did? Nobody wants to tell me? Did any of you take my advice of when you learn induction? I think they call it mathematical induction in 191. When you learn induction, think of recursion. It's two sides of the same exact coin. You have your inductive hypothesis. When I say assume that your recursive call is correct, that's your inductive hypothesis. You're going to assume that you're true on n minus 1, or n, depending on which way you're setting it up, and then prove that it's also true for n or n plus 1, depending on what you're doing. Either assume it's true for n minus 1 and prove it's true for n, or assume it's true on n and then prove it for n plus 1. It's the same thing we're doing here. We're assuming it's true for the smaller call, or n minus 1, and then we're using our logic to make it true for n. Same exact thing we're doing, and then we need something to start off the chain reaction. That's our base case, and it's called the base case in induction as well. As long as you have those steps, you can start at the base case and then build your ladder all the way up to infinity. We're doing the same exact thing with recursion. Start with our base case, and then if everything else is set up properly, we're building that ladder all the way up to infinity, and it's correct on every input. And yet, like I said when we first covered merge sort, you'll see merge sort at least a few more times in your careers. We love using merge sort to teach things. It's got so much packed into it. Like, it's not too complicated code-wise, but there's a lot going on with it. It's a lot of topics we get to teach. Let's talk about towers. So we saw this, I forget when we even saw it, but we saw this briefly, the towers game at jessehartloff.com if you want to go back and play it. It's been running for, actually I can check. It's been running for 13 months, so for at least 3 semesters now. So you can always go there and play it until things crash, which hopefully won't happen. If it made it this long, it's pretty robust. My code's fine. So we talked about how this works. I can go over more details maybe later in the week if we have extra time. Maybe I'll just go into more code or show a different app. Maybe I'll get sick of towers and show something else. But what I want to focus on is how I got this deployed to the internet. We wrote a lot of Scala code this semester. You wrote tons of Scala code. We learned how WebSockets worked to be able to get an app communicating via WebSockets, which this is no exception. Our Tower server is the main entry point. Tower server is going to start this WebSocket server using socket.io and then listen for a few different things: connections, disconnections, and key states. Key states is the big one. The front end is always going to send over this WebSocket connection which keys you're currently holding down or lifting up. So it could say this user is holding left, right, and up. I don't know what they're doing. Then the server is going to figure out what to do. Do they move up? Do they not move at all? I forget what exact decisions I make for that. If you're holding up and to the right, you're going to move up and to the right, etc. But it's going to send your key states over to the server, and the server is going to decide how you're going to move. So we have this WebSocket thing set up, which is fine. It runs the whole game through an actor system, and it has the WebSocket side communicating with the users. But that's only one piece of this puzzle. We need quite a bit more to be able to get this thing working. Most specifically, we need an actual web front end. We need our HTML and our JavaScript. I don't have any CSS for this page. It's literally just a canvas. It's an HTML5 canvas, and then I use JavaScript to draw on that canvas. So there's no CSS involved. I could add some if I want to, but I don't feel like it, because JavaScript does everything I need. So when we host this, we need some way to be able to access these files. Like when I run it locally, I can just open index.html, and that works for me. That works for us on the homework assignments. When we have a web front end, you run the server, you open the web front end, it talks to localhost, and that's fine. But when it's over the internet, you have to download these files somehow. And we don't have anything in our Scala code which is doing that for us. There are ways to do it in Scala itself, but I went with a different option. I decided to use Nginx with some configuration to be able to host these files. So what I'm doing here is running what's called Nginx, which is a web server which is going to host those files on the internet for me. Nginx is going to be my entry point. Whenever you connect to my server, Nginx is going to be listening, and it's going to handle any of those requests, those HTTP requests. It's going to handle any communication between a user and the server and decide what to do with it. So I wanted to do two things. I misread that. I want to host my web front end. So if you make a request for anything, this is going to match anything, the slash, host files out of this directory. If they request literally root, serve index.html. So there's nothing special ever about index.html. We usually name our homepage index.html, but there's nothing special inherently about that name. But we usually set up our web servers, and some of them are even set up by default, to host index.html as our homepage. So I'm setting that up manually here. I'm saying index.html is my homepage. So I'm hosting any of those files, so I don't have to go into Scala and host these files. If we get a request for /socket.io, I'm going to use what's called a reverse proxy to forward any communication over /socket.io to my Scala web server, which I'm going to have running on port 8080. So I'm going to run that app on listening for WebSocket connections on port 8080, and then Nginx gets a request for socket.io on port 80. I'm going to forward that request to port 8080 and say, hey, Scala, this is for you. And then I'm going to forward some headers. These headers are required for the WebSockets to work. If we don't forward those headers, WebSockets won't work. And I don't do anything with this, but just in case I did, forward the IP address for the original request. Because the IP address for this request is going to be localhost, because we're communicating within one machine between two different, effectively, services. So I'm going to forward that IP address of the requester, of the original user. For towers, I don't use this, but this is useful information for a variety of reasons, usually tracking reasons. You want to know what IP address somebody's connecting from. So Nginx is going to listen for those connections. And I'm going to use something called Docker to be able to run everything for this app. What I want is to be able to go to my server, run one command, and have everything boot up. That's what Docker and Docker Compose are going to do for me. These are topics I spend, I think, 2 lectures on in CC 312, and I'm going to cover it in like 5 minutes right now. So you won't understand everything that Docker does, or maybe you will, I don't know. But I'll give a quick overview of it. Docker is going to run an app. It's going to build what's called a container, which is like a very lightweight VM, and run our app inside that container. Run each part of our app, I should say. So I'm building a container to run Nginx, and I'm going to use a pre-built container for this. I'm going to download and run the pre-built Nginx container that Nginx offers, and then I'm going to copy my configuration files and all of my front-end files into that container, and then have it listen on port 80 for connections. And in my configuration file, I'm also listening on port 80. Those have to match. I'm going to expose port 80 to the world. So that gives me all these files hosted and the socket.io library. I'm self-hosting this library. You can see all kinds of code, yay. And then you connect to this and get my front end. I also want the server running. So my Docker file for the server is a little more complicated. I'm not just using a pre-built image and just using that verbatim. I am using a pre-built image, but I'm using a pre-built Ubuntu 18.04 and starting with a fresh, clean install of Ubuntu and then doing what I need to do to get my app running on that. This includes a lot of installing and updating. And Docker, I'm starting with Ubuntu, and then it's any command that you would need, starting with a fresh install of Ubuntu. What commands would you need to type to be able to get your app running with brand new, fresh Ubuntu? That's my goal here. So I have to install a few things. The JDK, I need to install Scala. I forget what that's for. This stuff I didn't need. I need to install Maven. Maven's installed with IntelliJ, but I have to install that manually here. It doesn't come with Ubuntu. I'm going to set up my working environment, my directory, my home directory, my working directory, copy all of my files into the container, and then run Maven package. This is going to tell Maven to build my app with, well, let me get through the end of this and I'll come back to that one. And then expose port 8080, that's where I'm going to be listening on. And then build an executable jar to run my app. I'm going to do this through Maven. Maven package is going to build this executable jar file, and then I'm going to run this executable jar file as my command. By the way, we won't finish this today. I'll continue this on Wednesday. But I want to get through the Maven stuff at least. So to do that, I have to do a little bit extra in the pom.xml. So we've been using the pom.xml to specify all of our dependencies, which are all the external libraries that we use, any library not included with Scala. But I also have to add instructions on how to build this executable jar. I want to build a jar file, an executable jar, with all of those dependencies. So I'm saying, Maven, download all the dependencies, build a jar, and when you build that, make tower server the main method when you execute this jar. And then with all these instructions, which is so verbose, I'm not a huge fan of all that. I have to do all that just to say, make a jar, include the dependencies, and run tower server when this is called. But what does that mean? So I want to hop back to the CSE examples for this. What does it mean? What does an executable jar even mean? So I want to go to GUIs. We built this GUI 2D a long time ago. This is one of the first apps that you run in that first lab where we're just setting up IntelliJ. There's a circle and spinning rectangles when you click. And I want to build this in a way that I can run it without using IntelliJ. So I want to run this code, and I want to share it. I want to put it on a flash drive or email it to somebody and have them run my software without me saying, install IntelliJ, get JDK. No, not that JDK. Now install Scala. Not that Scala. You don't want to do any of that crap when you're like trying to show this to your parents or your friends who aren't CS majors. So what we're going to do is, oh my goodness, let me make sure I remember. I thought it was in build, but there's no options there. Shoot, I should have done this right before lecture. No, I remember. It's coming back to me. I want to go into project structure. And I want to go to artifacts. And I want to add a new artifact. And I want it to be an executable jar. I think it is just jar from modules with dependencies. And I'm going to choose my main class for that jar, which is going to be one of these, GUI 2D. And I want to, I think that's it. And then I want to build my project. So I'm creating an artifact, I'm selecting jar, and then I'm selecting the main method for that jar. So I have lots of classes with main methods in this project. It's going to say, okay, when somebody executes this jar, which main method should I run? So I'm telling it which main method it should run. And then when I rebuild the project, I should have an extra directory here. Oh, no. Don't do this to me. There'll be an extra directory called out, which is going to contain my jar. Hopefully. It's got me nervous it didn't show up the first time. No, you're killing me. Include in project build. Why would that not be default? Goodness gracious. Well, why would I not want to include that in the build? I guess if I'm in dev mode, I don't want to. All right, well, there's our out. And I'm going to get this artifact. I'm going to open it in Finder just to kind of prove that I don't need to be in IntelliJ. And this jar is a self-contained, is the project completely self-contained? Any machine that runs Java, which is like just about any device ever, can double click on that thing and run it. So now I can play with this, I can show people, I can email this to my parents and say, hey, look at this cool GUI that I built for my lectures, and they can run that app. So if you want to build something in Scala and share it with somebody, executable jar is what you're looking for. And if you forget exactly what I did there, just Google IntelliJ executable jar. It'll get you what you want. It'll get you to that. So this is running completely independent of IntelliJ. I can shut this down. My thing's still going to run. It has nothing to do with IntelliJ at this point. It is a compiled Java bytecode application contained in a jar, which is a Java archive, which is an archive of Java bytecode. So anything running Java can run this code now. So if you want to deploy your stuff and share it, that's the answer to that, which we'll pick up on Wednesday at that point. So we built an executable jar, and now we're running the executable jar when we run our app. I'll pick that up on Wednesday, so I'll see you then.